Welcome back. In this video, we're gonna learn how to build for loops in Python. For loops, let us repeat actions automatically, counting, iterating, or processing data without writing the same code multiple times. In this video, we will start simple, break down every detail step by step, and by the end, you'll be confident using for loops in your Python programs. Here is the structure of a for loop. For variable in sequence, the keyword for starts the loop. The variable takes a new value every time the loop runs. It is called iterator that used to iterate through the sequence. The keyword in tells Python where those values are coming from, and the sequence is the source of values. This could be numbers, a list, or even text. Then we add a colon at the end and indent the block of code we want to execute. In Python, one of the most common sequences we use is range. Let's quickly understand how it works. The function range creates a sequence of numbers. We can pass it up to three values: the start, the stop, and a step. A start value is where to begin. If we don't give 1, Python starts at 0. And the stop value is where to end, but remember this is exclusive. The loop will stop just before this number. And the final is the step value, how much to increase or decrease each time. By default, the step is 1. Now let's see examples. Example 1 is looping with a start and stop. First, let's write a loop that counts from 0 up to but not including 5. For I in range 0 up to 5, 0 is the start, 5 is the stop. Then the block of the code is print I. The loop starts with I equal to 0. It prints 0. Next, the value of I will be increased by 1 after printing out the I value. Then next run, I is 1, it prints 1. Then I becomes 3, it prints 3. Then I become 4, it prints 4. Now I become 5. The loop stops because when Python reaches 5, the stop value, it ends the loop. This is like floors in an elevator. If the building has floors 0 to 4, you stop at each one, but you never actually reach floor 5. That's just the limit. Example 2. Using only the stop value. Sometimes we don't need to specify a start. If we just give a stop value, Python automatically starts at 0. For example, for I in range 6, print I. This loop starts at 0 by default and counts up to 5. The output is 0, 1, 2, 3, 4, and 5. Notice that we gave 6 as the stop value, but 6 itself was not included in the output. This is like numbering chairs from 0 until you run out. The total number is 6, but the last chair is number 5. In example 3, let's use custom start and stop. Next, let's define both where to start and where to stop. For example, for I in range 10, the start is 10 and the stop is 15. And now print I. So this begins at 10 and goes up to 14. The loop prints 10, 11, 12, 13, and 14. At 15, the loop stops. Think of a sports match ticket numbered from seat 10 to seat 14. You sit in those seats only. Seat 15 is not included. In example 4, we add a step. Now What if we don't want every single number? What if we only want every few numbers? That's where the step value comes in. For example, for I in range 0, 25. 0 is the start value, 20 is the stop value, and 5 is the step value. So the I value will increase by 5 in every iteration. Let's trace it carefully. It starts at 0 and print 0. Now the I value increased by 5 in the next iteration and it become 5 and print 5. Next, the I value increased by 5 and it become 10, then it print 10. Then 10 plus 5, the I value become 15 and it print 15. The next step would be 20, but the loop stops just before it. So the output is 0, 5, 10, and 15. This is like counting money in $5 bills instead of $1 bills. And example 5, counting backwards. We can also count backwards by using a negative step. The steps don't always have to be positive. A negative step counts backwards. For example, for I in range 50, 0, minus 10. The start is 50, the stop is 0, and the step is negative 10. So the I value going to be decreased by 10. First, I equals 50, print 50. Next, subtract 10 from I value, that is now 40, and it print 40. Then subtract 10 from the I value, and it become 30, and it print 30. Then when subtract 10 in the next iteration, the I value become 20 and print 20. Then subtract 10, the I value become 10, it print 10. The next step would be 0, but the loop stops before it because the I value is 10 and we subtract 10, it reaches to, it is 0. So 0 is the stop value of the loop and the for loop exclude the stop values. So we get 50, 40, 30, 20, and 10. This is exactly how a countdown timer works, starting high and moving down step by step until it reaches the stop value. In example 6, we use nested for loops. Finally, let's see what happens when we put a loop inside another. This is called a nested loop. Here is an example. For I in range 1 to 4, then we add another loop inside this outer loop. For j in range 1 to 4, then we print the value of I and j inside the inner loop. When you execute this program, it starts from the outer loop, that is for I in range 1 to 4. So the I value is 1 and it goes to the inner loop. The inner loop j value is 1. So it prints I and j. So the output is 1, 1. First run j equals 1. It prints 1, 1. Next, it continues iterating through the inner loop, not outer loop, until the inner loop reaches to the stop value. So the j equals to 2, it prints 1 because I value is still 1. Next, the j value becomes 3 and print 1, 3. Now the j value reaches to the stop values of the inner loop and now it goes to the outer loop and increase the value of I by 1. So the inner loop finishes. Now the outer loop moves forward. It continues to the inner loop starting from J1 and the inner loop runs again. Then the J value is 1 and the I value is 2. Then it prints 2, 1. Then J equals 2, it prints 2, 2. When j equals to 3, it prints 2, 3. Now it reaches to the stop value of the inner loop and it goes back to the outer loop, I becomes 3. Now I equals 3, and the inner loop runs last time. So the j value starts from 1 and it prints 3 1. J value 2, it prints 3 2. J value is 3, it prints 3 3. Now the inner loop reaches to the stop value and it goes back to the outer loop, and the outer loop becomes 4, but it reaches to the stop value as well. So now the loop is terminated. Think of it like a timetable. The outer loop is the day of the week, while the inner loop is the hours in that day. And that's how for loops work in Python. We started with the basic structure, learned how range function controls loops, explored start, stop, and step values, and even built nested. For loops are everywhere in Python programming, from counting to generating data to building patterns. In the next lesson, we will look at while loops, which run until a condition is no longer true. Thanks for watching.